Hi everyone, in this video we are going to learn two important concepts which are useful for analysis of the data, especially genomic data. There we use these two concepts very much. So first one is the data normalization, second one is squaring the data. So coming to the data normalization, how we do data normalization and why we do the data normalization, that we are going to learn. And then squaring the data also, there how we where we learn how to do the squaring of the data and why we do squaring of the data. So coming to the data normalization, so before going to understand the data normalization, I will give a one classical example, very general example for normalization. For example, there are two students, suppose student A and student B. Student A got 95 marks for 100, and student A got 45 for 50 marks. And just by comparing these two students with their total marks they got, uh, without considering the maximum marks of the exam, if we take a decision that student A who got 95 marks out of 100 is a got highest marks or is a best student, so that interpretation going to be not that interpretation going to be wrong. Why? Because the student B, he wrote exam for 50 marks, but student A wrote exam for 100 marks. So to normalize that, what we generally do, we generally scale up the student B marks to scale A by multiplying his total marks with the 2. And so by these two ways we can normalize the data. We can bring the students of these two students marks onto same scale. So a similar approach we use in data science also. There we need to normalize data at sometimes, because many reasons that I'm going to explain now. For example, it's a genomics. If it is a genomics experiment, there we may sequence data on two different machines which have a different capacity of reading these sequences. For example, machine A, it reads totally 10, suppose 1 lakh reads in a sample, and machine B, it reads 10 lakh reads in a sample. And in such case, for a gene A, suppose 500 reads are present in out of this 1 lakh in a sample A. And the for same gene in another sample, where you may get suppose 5,000 out of 10 lakhs. Just by comparing these two, saying that B sample where the gene expression A is more is going to give a wrong interpretation. Therefore we generally normalize this data, the same similar approach, by taking the percentage gene A count divided by total reads in that particular sample. So like the marks how we calculated for 50 marks and 100 marks. So that is one approach. This we use data normalization. And also we use the log transformation also when we compare two samples. For example, for a gene, suppose there are two genes whose reads are for gene A reads are 500, and for gene for example, for the same gene in another sample there 5,000 are there. So to comparing this, before analyzing this data, so these values may be log transformed also, so that that data becomes normal for analysis. So that data normalization process is very important process. Whenever we have a sequence data, we normalize this to avoid the technical noise or unnecessary noise which is present other than the biological difference between the samples. So because now when we take such samples and we calculate the mean values and we compare with t-test or some other test, so what happens, definitely the difference which comes because of this noise, technical noise, may leads to the taking a decision where where we fail to where we yes, where we reject the null hypothesis, that there is a difference between the two samples is not present. So we fail to we reject the null hypothesis, and we say that the difference between these two things is not by technical noise or the random by chance. We say it is a purely a biological difference present between the two samples. This is one aspect where we use this one. So there are many log transformation, or even G transformation, or even Z score transformation. So all these transformations are used for data normalization in different contexts. Depends on context and different scenarios. We use different normalization methods. The other one is a squaring of the data. So in a data normalization where we convert the higher values to the lower values, that is one aspect, or we bring generally to the same scale, that is one aspect. So in the squaring the data, where we actually we multiply the, or we square the data. That is a very interesting thing. So especially in the linear regression, where when we try to draw a linear line, so where the errors the distance between the data point to the line, the error, so that errors are multiplied or squared in this particular aspect. Why? Because when we take these values, there you will have the positive values and negative values, so finally we'll get a zero error. So we draw a linear line where we try to see that the error rate, the total error is likely to be less. So when we try to show that the error is likely to be zero or small, so when we take the exact values, that negative and positive values, definitely though the line is not correct, we get the zero. So to avoid that, the data errors are squared in the this particular example, so that the negative values become even the positive values, and so that the highest error values becomes even more highest. And when such values are taken, and when such values are taken to find out that least square for the least square calculation, definitely we get a exact or minimum error value, and so that we can make a decision on that. Okay, that particular linear line is a best fit line for that particular data. So this is another aspect of the data squaring, which is different from the normalization. So even for variance calculation also we use this one, and for linear equation also we use the squaring of the data. So other side, the data normalization, which is used basically for the genomic data, where the raw counts are present, so where we use the data normalization much more. So this is about this data normalization and squaring of the data. So thank you for watching this video.